Well, I have to say, that was quite a warm welcome. Everybody who's asked me to sign books and take pictures is very nice of you to do that. Anyway, this is my first time in Russia. I've traveled all over the world, but I've never been here before. So this has been great, and I saw St. Petersburg yesterday. I went on a guided tour, and it was fantastic. I got a lot of photos of things, and then I'll be going to Moscow, of course, for the .next conference very soon. So they asked me that, so I wasn't going to come to St. Petersburg at all. I was just going to go to Moscow. And then I said, well, if I only come to Russia once in my whole life, I probably need to make it to St. Petersburg. So I arranged to fly out here and spend a couple days here and then go to Moscow in the morning. So this was purely just for fun for me to come here. And then they said, well, while you're in St. Petersburg, we have this .NET meetup group, and if you're just going to be here anyway, would you just come and go and spend some time talking to you people? So I said, sure. I love what I do. I've always loved what I've done. I love presenting material, and I love meeting people like yourselves and so on. And so this is actually a lot of fun for me. So hopefully it'll be fun for you too. So they asked me to, what could I do? And the latest thing in .NET that's kind of big and meaty, that has some interest to it, is this new Span of T type. And actually, I had heard about it, I'd read about it, but I hadn't actually worked with it at all. And then when I decided to do this talk, I spent several days last week, maybe it was a week before now, I've lost track of time, but recently, and I built this slide deck of 2 whole slides. Yeah, it's just for you. But more importantly, I built a demo, and so I'm going to be stepping through a ton of code in the Visual Studio debugger, and this is how I learned it too. I wrote a bunch of code, and I tried this, and I tried that, and then I try to put it in an order of this would be useful to people actually trying to use it, so that it's productive. So that's eventually what I'll be showing you, is this demo of all these different things you can do with Span, and hopefully things that are like really valuable and useful to you, things that you can do with Span. So it's really all about efficient buffer manipulation, and it does require that using the C# compiler version 7.2, but it runs on any version of .NET framework. So you need this version of the compiler, but it runs on any version of the runtime. I am your host. My name is Jeffrey Richter, if you haven't figured that out. And a little bit about me, I always do this slide. So I now work at Microsoft. I've been there about 3.5 years now as a full-time employee on the Microsoft Azure team. I was on the Azure Service Fabric team for almost 2 years, and then for about 1.5 years, I was on Azure Storage team. And so I'm a software architect on Microsoft Azure. Most people know me from the books that I've authored, many of which you've asked me to sign. Interesting how the Russian one's in pink. I wouldn't have chosen that myself, but that's fine. It's fine. It's good. I did see the German version once, and it's like this thick, the book is, because the German words are so big. Anyway, I do have some foreign language ones at home, and I can't read any of them. It's odd. People come over and they say, is that your book? I said, I think so. But I don't know for sure. Anyway, my latest book is the Windows Runtime via C# book. That was for Windows 8.1. That's a really good book if anybody cares. But and that's the problem. There's a lot of stuff in there that you couldn't get anywhere else, but not a lot of people are building Windows Store applications, which is really what it's designed for. And then, of course, there's the CLR via C# book, which many of you have the pink version of. And then there's the Windows via C, C++ book, the 5th edition. Anybody have that book? Yeah? A couple people have that one? Okay, that one's really old now. And people always ask me, will I be revising the CLR via C# book for .NET Core? And my current thinking is no, that I will not be doing that because people don't buy books. And I feel like I spend all these time and effort and I write these books, and then I'm not so sure who actually reads the books. I think you people read the book because you're interested, right? You're here at an extracurricular thing, right, that you don't have to go to. But a lot of companies, programming is their job. It's not their passion or their love, right? I think for you people, it's your passion and your love just by nature of you being here. So you might buy it, but I don't know who else would really buy it. But I haven't completely ruled it out. There's a chance I will do it, but I'm leaning towards no. On the other hand, though, my most recent book is not a book, but I have done this video series. Let me move this window out of the way because there's a little bit more there. I did a 6.5-hour video series. It's a technology agnostic course. That means it's not about Azure. It's not about Amazon. It's just about how to architect distributed cloud applications. This is my latest book, if you will. It's just that it's a set of videos. 6.5 hours, 53 videos in all. It's completely free. And it's available on YouTube. And if you go to edX, then there's collateral material. And if you want to, you can pay them. It's $99. I don't know what it would be here, but then you can get a certificate. I don't get any of that money, by the way, so I'm not trying to sell you anything. So anyway, I encourage you to check that out if you're building or architecting distributed cloud applications. I've gotten a lot of very positive feedback on it. It introduces a lot of terminology and concepts and how they all relate together. And the reason why I did it was because when I was on the Service Fabric team at Microsoft, I used to meet with customers all the time. And we would talk to customers about storing their data in Service Fabric. And then the questions would come up, how should I partition my data? How many replicas of my data should I have? Do I need a load balancer in front of my servers in order to access the data? How do I do versioning of my application code? How do I do versioning of my schema for my data? And when I was talking to these customers, they didn't know the answers to any of these questions. They didn't even know what replicas meant. They didn't know what partitioning meant. They didn't know what a container was. It was surprising to me. So we had a very hard time selling people Service Fabric because they couldn't appreciate the value that it brought them. So it was after many of those, like a year or more of conversations, I realized that the world at large doesn't really understand all these things that are involved in architecting distributed cloud applications. And so that's why I went and built this video series. Okay, at the bottom left is ways for you to get in touch with me if you'd like. There's my email address there. It's my private one. There's a LinkedIn if anybody wants to be from me. Although I've noticed that LinkedIn doesn't seem to work here from... Yes. So if you can figure out how to go through a proxy or something and get on that, I will be happy to accept your friendship there. And then Twitter at the bottom. What's the deal with LinkedIn? Facebook works, but LinkedIn doesn't work? Usually when I go to China, and I've been there several times, I'm shut off completely, right? I can't do anything there. Google doesn't work, Hangouts doesn't work, LinkedIn doesn't work, Facebook, well, LinkedIn maybe I think does actually. Facebook definitely does not work. A lot of stuff doesn't work. Here I've had really good success, except for LinkedIn for whatever reason that does. Okay, and then my Twitter handle's down there at the bottom. Okay, so this slide, I would recommend you take a picture of it. So what happened was, a little background, was that I had read some things about this span of T type in .NET, but I didn't fully understand it. And so I sat down and I started writing some code to figure out how it worked. And it doesn't take you very long when you start playing with it that you realize that there's not just a span of T type, but there's also a read-only span of T, as you can see on the first row of this table. And not only is there a span of T and a read-only span of T, but there's also some other types called memory of T and read-only memory of T. So now this one type I thought I was going to learn has now turned into 4 types that I feel I really have to learn because clearly there's a close relationship between the 4 types. So then I said to myself, so if there's 4 types, they look almost identical, but they're not completely identical. There's some things that are different about them, but there's a lot of things that are the same about them. So I started to make a table and said, okay, so let me go down the span of T column and read-only span of T. So these 2 things have something in common, which is that they must live on the stack, and this is compiler enforced. This is why you need the C# compiler 7.2, is because it has some built-in logic in that compiler to enforce that span of T and read-only span of T instances only can ever live on the stack. Memory of T and read-only memory of T, they can live on the heap, typically as a field inside some other class object or so. Okay, and then, again, it took me a while to produce this table. I'm not going to walk through the whole table, but if you're trying to use this technology, I would recommend you take a picture of this again, as I said, because this really summarizes the comparisons and contrasts between these four types. So all four of them can be constructed the same way, like from an array of t and possibly put a start index into the array and a length of the array. The spans can also be constructed from a void star and from a length. The memory t's cannot, but they can't refer to native memory unless it's through another level of indirection. Again, I'm not going to walk through this in detail. I'm going to go through it in code instead in Visual Studio. I'm just trying to show you now how to interpret this table. So there's conversions. From span of t, there's an implicit conversion from a memory of t. And for read-only, there's an implicit conversion from span of t. Oops, I went the wrong way. And there's no implicit conversions to a memory of t. But there is an implicit conversion from a memory of t to a read-only memory of t. Right, so this shows you the relationships and how you can morph one of them into another one to do something different with it. Okay, these members here are common to all four of those types. The span of t has two additional methods on it, clear and fill. This is the most important line, this row right here. The span of t has a getter and setter for indexing. The read-only one has a getter, but no setter, because it's read-only, so that should make some sense to you. And the memory t's, they have no indexer at all. That's actually very key that you understand, that there is no indexer, which means you cannot get or set any element using a memory or read-only memory of t. You can only access elements using a span of t or read-only span of t. The rest of the rows here are really not that interesting. Okay, so now that kind of sets you up a little bit. But to make it more interesting, we'll now go to code. So let me explain what is the purpose of this. When .NET was being created, 16 years ago? Oh my gosh, I'm so old. I was on the team back then. I was on the .NET team, the Common Language Runtime team, for 8 years, actually. I left right after .NET 2.0 when we added generics into the system. I went to another team, the Windows Communication Foundation team. I was there for a little while. So when .NET was being created, it was really largely about productivity, programmer productivity. We wanted it to make it easy for programmers like yourselves to write code quickly and easily, and memory safety was really the number one feature. After productivity, I guess you want to say. So productivity is important, but memory safety is also very important, which means a string can only ever be managed as a string. If you come from the C, C++ world, which is what I did prior to being a C# developer, then you know that in C and C++, you can have a pointer to a rectangle, you can then cast it to a string, and then you can uppercase the rectangle, which makes no sense, but it's allowed to happen. The code will compile, the code will run, and you will end up corrupting memory. With .NET, one of the main features here is it is a memory-safe language, and that you can only manipulate a string as a string. You can't convert it to a rectangle unless you use unsafe code, but unsafe code requires all kinds of permissions and special privileges and whatnot. Oh, by the way, as I'm talking, if anybody has a question, feel free to ask the question as I go. So that was great. This memory safety thing is great, and this productivity thing is also great, but the .NET was not designed to be very memory efficient. It was the high order bits where the productivity and the memory safety, and much lower priority on the set of features to give you is efficiency. And it's garbage collected. So the more memory allocations that you create in your program, the more frequent the garbage collector is going to run. And the more frequent the garbage collector runs, the worse your performance is going to be. So some people have struggled with .NET because they do run into performance issues with the garbage collector. And this span of T technology and the other helper types, memory T and so on, those were introduced to make it so that programmers like you and me, if we are concerned about improving performance in our applications and reducing memory allocations and reducing garbage collections, we can now use these types. in order to make our programs run faster. All right, so that's the setup. So now I'll give you an example. So here, I'm creating a variable name of type string. I was just going to say, do you want the font bigger? And I want to say yes to that. Oh, right there, yeah, okay. Didn't it used to be in the lower right? Is that good? Yes? How about way back there, the people in Moscow or some other, good? All right, you're so far away. Okay, all right, so here I have a variable name, and it's of type string, and I'm initializing it to my name, Jeffrey Richter. Now, a common thing that people will want to do is they'll want to take a string that has, let's say, some delimiter in it. In my case, I'm using space as the delimiter, and I want to separate the string into the first name and last name. So what I do is I say name index of, and I find the index of where the space is in that string. And it comes back, and it says, number 7, okay? At index 7 is where the space is. Now, if you wanted to get the first name and the last name, what you would normally do as a .NET programmer, this is the old-fashioned, low-efficiency way, is you would say name.substring, and we want to start at index 0, and we want a length of 7 to where the space is, and now I will have the first name. And if we hover over first, you can see barely that it says Jeffrey there. Now, the problem with this is that substring, especially because strings are immutable, substring has to allocate a new string on the heap that has Jeffrey in it. So now we really have the string Jeffrey in the heap twice. It's in here once because it's embedded in this big string, and then this went and created another string with Jeffrey in it. And now, to get my last name, I'll say name.substring. We'll do space plus 1, so starting at index 8, and we'll go to the end of the string, and that goes and gives me Richter when I'm all done. And then to prove that it worked, I'll do this console write line here. That's why the console window's there. And we can see that the first name is Jeffrey and the last name is Richter. Right? But what you don't see, it's immediately obvious anyway, is that these two calls to substring allocated new strings on the heap. Right? And that's more memory pollution, causes the garbage collector to kick in more frequently, and hurts the performance of your application, and causes its memory consumption to increase as well. Okay, so now let's rewrite this code, but we're going to rewrite it using the new span of T that I was just talking about on the slide. And now you'll see that we can do the same exact thing, but without any memory allocations, and so the performance is dramatically better. I don't demonstrate the performance, but I'm hoping you can imagine, as I go through this explanation, that you can see that no memory allocations are happening, and therefore it will perform better. So on my variable name, which is of type string, there's a new method now called asspan. This goes and returns back to me a span. Now, it actually is returning back to me a read-only span. That's right, because strings in .NET are immutable. If I want to go and access the elements of the string, I have to access them in a read-only fashion. I can't write to them, otherwise we would have memory corruption since strings are supposed to be immutable. Also note that read-only span, like I said on the slide here, by the way, although I didn't point it out at the time, here, no, wrong button, this one here, okay. Right, as I mentioned here, these are value types. Okay, all 4 of them, span of T, read-only span of T, memory, read-only memory of T, all 4 of them are value types, which means that they can be allocated on the stack and not allocated on the heap. So when I go back to this code here and I call as span, this is returning to me a read-only span. This did not cause any heap allocation to occur. So it's very efficient in terms of memory consumption. It consumes no memory, just a little bit of stack space. All right, so now that I have this read-only span, which I put in a variable called namespan, and by the way, this is a read-only span of char, since strings consist of chars, characters, I can now say namespan and give me a slice starting at offset 0 up to index 7. This returns back to me also a read-only span of char, but it's the portion of the first name, so it has Jeffrey in it. But it's really indexing into the original string, so it's not allocating a Jeffrey string on the heap. It's just indexing into the Jeffrey of the original string. And now here I'm taking name span and I'm calling slice and I'm saying space plus 1 just like I did up here when I called substring and passed in space plus 1. And this is going to give me a slice from Richter, the R in Richter, all the way to the end of the string. But again, this is indexing into the original string, not creating a new string, and so it's very memory efficient. And now I can write to the console window, here's first equals, and then this is a write method that I wrote. I'll step into it to show you what it looks like. It iterates through each of the characters in this read-only span of char, and then it writes out each character here. And the reason why I did this, anybody want to guess why I did this? Right, not to allocate a new string. Because if I called regular console write line and I passed in a read-only span, it would call toString on that, which then screws up everything I just did. So in my opinion, the console class, they should add a write overload and a write line overload that take read-only span of chars, but those don't exist yet. So they might add that in the future, but they don't exist today. But if they did exist, I bet they would look a lot like this right here. All right, so that's how I wrote this whole out, and I ensured that there was no memory allocation that occurred. And now here I'll say last, and then I'll call that same method again. I won't step into it, I'll step over. But you see I get the same result, right? So I get the exact same result as I got before, but without the memory allocations. And so my performance is better, my memory consumption is lower. Are there any questions so far? Yeah, go ahead. What does it store inside a read-only span? So, in my table here, let's go and make it full screen. A span and a read-only span, they have a pointer and they have a length field inside it. So it's basically the pointer to where the string is in memory and the length of that section. And the pointer points to the beginning. Read-only span has the exact same thing as span. The difference is in the indexer, right? A read-only span only has a getter, so I can get the characters out, but no setter, so I can't change any of the characters in. Okay? Yeah?
Is it always the entire point of string only that region?
It's only that region. So when I create a span and then I slice it over Richter, this pointer points to the R in Richter, not to the beginning of the string. Oh, no, and it does prevent the entire string. No, yes, I misunderstood. Yes. So if you have, it's called an interior pointer. If you have a pointer to the interior of a .NET object, and a string is one of those kinds of things, that prevents the entire object from being garbage collected. Yes?
What about a span method? Is it your method or?
No, that's a framework-provided method. The asSpan method over here, I don't remember if it's, I don't think it's an extension method. I think it's on string. I think it's only on strings, but there is an extension method that would work on arrays. Well, I don't know what it's doing now, but I was trying to go to the definition so I could show you where it was defined. Was there another question while I was trying to figure it out? Yeah, see, resharper or something would have been a better choice. Oh, okay, so it is an extension method on string as span, and then there's other ones that are on arrays. Yeah, go ahead. Right, so span cannot be boxed, and the compiler will see if you're attempting to do that, and it will not compile the code. Okay. Yes?
Except of that, what's the dramatic difference between span and, let's say, array segment? So,
array segment? The difference is that almost nothing takes, well, array segment was never fully adopted. There's a ton of APIs that just don't take it. If it was more formally, oh no. All right, so was there another question? I'll just, go ahead. No. Can you use an initializer? I'm not sure what that sentence means. You can new up a span, it has a constructor, and then you can pass it an array of t. Yes. Yeah, and in fact, I'm going to be doing that a little bit later on, so you'll see that. All right, is there one more question? I'll take one more question, and then I will go into back to the demo. Okay, we look good. All right, let's go do this back to the demo. Oh.
Does Span of T works for others collections?
An array of T. Yeah, so if you have the collection must be an array. That's the only kind of collection that it works on. You can't create a span out of a list of T. You can't create a span out of a dictionary of T key T value. You cannot do that. You can create a span out of an array of T. The memory has to be contiguous, that's why. And arrays, the elements are always guaranteed to be contiguous.
Is it possible to create span of custom objects?
You can create a span of a custom object from an array of that custom object. Right? If I have a rectangle, I define a rectangle type. Then I can go and create an array of rectangles. Then I can create a span of rectangle of that array of rectangles. Okay? So actually, I'm kind of going to demonstrate that now. Instead of rectangle, though, I'm going to use int32. Right? But replace int with rectangle, and everything is still fine. Right? Or replace it with, foobar or whatever, and everything is fine. So here I'm newing up an array of T, right? My T is an int32, and I'm initializing it with 1, 2, 3, and 4. So here's an array that has 4 elements in it. Index 0 has the number 1, index 1 has the number 2, and so on. So this is just a regular .NET array. Now this allocates an array object on the managed heap and initializes the 4 elements of that array object. Now I wrote a function called processArray, and I'm passing this into it. Now I'm going to hit F11 and show you what the function looks like. The function is called processArray of T. This was written by me, by the way, so this is part of my demo code. And it takes a T array, right? So an array of some T. And what it does internally is it calls an overload of this method, also called processArray of T. But the overload wants a span of T, and I'm passing in the array here. So here I'm converting my array of T to a span of T, which is really exactly what you were asking. And if I hit F11, then it takes me to the overload right below. This overload takes a span of T. So this means an array of T's, whatever T is. And then all this method does is it's going to process these elements. In this case, I display the elements on the console window. Let me get the console window visible. Also, I need to do this. Just give me a second to say OK here a few times. This is my program that I haven't updated it. And so it gives me a bunch of error messages when I start. But then it makes this window be topmost, so I can come back over to Visual Studio, but the console window is still visible. OK, so now what I'm going to do is I'm going to walk through all the items in the span, because span has a getEnumerator on it, and I can walk through the elements of the span. So I'm going to get the first element, and I'll display it. There's the 1, there's the 2, there's the 3, and there's the 4. And I separate each element with a space bar, a space, as you can see. OK, and then I do a blank line. And now I leave the method and I come back. OK, now, let's say there's really not that much interesting there, but here's where it gets a bit more interesting. Let's say, oh, actually it's not just yet, it's soon. So another way I can do this is I can pass in net numbers, but then if I put in here int for the T, I say explicitly it's int, then the compiler automatically calls the other version, and we get down here. All right, but that's not that interesting either. So let's just ignore that part. Let's go here. This is where it gets more interesting. What if you want to process the array, but you want to process just a subset of the array, not the entire array? Let's say we wanted to process starting at element 2, and we wanted to do 2 elements. So we just want to process the 2 and 3. So how would you do that today in .NET? Well, what you would have to do is you would have to create a new array on the heap that's 2 elements big, which is what I do here on this line of code. I'm newing up an array of integers that has 2 elements in it, and then I call array.copy to copy from the original numbers array, starting at offset 2 or index 2, into my new number subset array, starting at index 0, and I want to do 2 elements that I want to copy. So I've had to allocate a new array on the heap. I had to copy the 2 elements I want from the original array into the copy, and then I can now go and call my process array function, where it takes in the array of t, it's calling this one right over here, and then it does, of course, work, and we see the 3 and 4. I started at 0, 1, 2, which is, and 2 elements was the 3 and the 4. I think I said 2 and 3 before, but I meant 3 and 4. So this works, but you've had to allocate this other array and you had to copy. But with span, you can do the same exact thing, but much more efficiently. So I'll demonstrate that now. So here I'm taking my numbers, which is the original array that has 4 elements on it on the heap. I'm calling the extension method as span, which converts it into a span of t, span of integer in this case. And then I'm going to slice the span, saying let's start at index 2, and I want 2 elements, a length of 2. And this returns back to me another span of int32 as the return type. So all this did was create a span, which is a value type allocated on the stack, not on the heap, that refers to the starting index within the managed array, and it knows how many elements you want. But it did not create a new array, and it did not copy anything over. Now, when I call this process array, it's calling the one that takes a span of t, because what I have is a span of t. And now I can go and process this. And in this example, no memory was allocated, and the garbage collector doesn't have to run in order to do this processing of this sub-array, if you will. Okay. If you want to make another copy of the array for some reason, then you can take that span, and you can call toArray on it, and this will allocate another array on the heap that has just the 2 elements in it and make a copy. But normally you don't have to do that. Normally you don't want to do that. Normally there's no need to do that. But if for some reason you did want to do that, there is a function called toArray that you can call on span to go and create that array. Any questions here?
Is it correct that span doesn't implement the INumberable?
No, span does. Yeah, so where is my PowerPoint slide? PowerPoint crashed, so I have to start it back up. That's why it's these kinds of questions. I had the same questions when I was trying to figure this out myself, and that's what caused me to go and create, where is PowerPoint? How about that?
So it seems that it uses duck typing in the for each.
Well, C# has always done pattern matching, where the type itself does not have to implement IEnumerable. It looks to see if the type implements a get enumerator, and if it does, then for each can work. And span and read-only span do implement get enumerator. Memory and read-only memory do not, by the way. So I don't know why PowerPoint's not starting, and we're not going to take the time to figure it out. It looks like there's another reboot in my near-term future tonight. Okay, next thing that's useful is you can cast a span of t to a span of a different t, of a different kind of t. Let's say, for example, that you want to allocate a buffer that's capable of holding 10 int32s. Well, you need to know the size of an int32. So I'm using the C# size of operator here on the int32, and that's going to return to me the number, anybody? 4, good, yeah. This is just to see if you're paying attention. Yeah. I'm assuming you're all familiar with the number 4 at some point in your past. You have that. So yes, this returns the number 4, and I want 10 of them, so I'm going to multiply it by 10. That gives me the number, yes, very good, 40. So now I am newing up a byte array that is 40 bytes in size to hold my 10 int32 values, and then I am passing that to the span of byte constructor. We all good so far? So now I have a span that represents this byte array that's capable of holding 10 32-bit integers, but it's a byte array. So the byte array has 40 bytes in it. And then this, of course, gives me back here a span of byte. So I call this variable my int32 buffer in bytes. So now I have this byte buffer, but I'm going to want to put integers into it. And in order to do that, I would like to cast the byte buffer to a buffer of int32s. So to accomplish that, we call the system runtime interop services in that namespace. There's a type called memory marshal. And this type has a bunch of static methods on it that you might want to look at when you're working with Span. The one that's interesting to us right now is cast. And this says, I want to cast my span of byte to a span of int32. And then over here, I pass in the original span of byte. This returns back to me, of course, a span of int32. So I have two different spans now on the stack. One to bytes that points to the array of 40 bytes, and another span that points to the same exact memory buffer now, which is the byte array, but now it thinks it's an array of 10 int32s instead of 40 bytes. Right? And then to prove it, I will do a console write line here, and I'll take my int32 buffer in bytes, and I'll get the length property of this span. Spans have a read-only length property on them, which gives you the length. And then I'm going to take the int32 buffer in int32s and get its length. And when we display it, you can see that it's 40 bytes over there, or 40 elements in the array if you want. And there's 10 elements in the array if you treat the bytes as int32s instead. So this is very useful when working with byte buffers, and you're allocating byte buffers, and you're maybe reading from disk or reading into memory. You read those bytes from disk, you read those bytes from the network, and then you put them into this buffer, but then you want to treat the buffer as an array of rectangles or an array of int32s or an array of something else. This is the cast method that lets you be able to do that easily. Yes, sir?
Two questions. First one is, what is the main mistake calculating the size of buffer? Let's say only 39 bytes and then cast it to this kind of...
It's a great question. So I tried that because I had the same question. And what you end up with, it takes the number of bytes that are in the buffer, it divides it by the number of bytes you need, and if there's insufficient, it rounds down. So I got 9 integers when I did it. I created a buffer of 39 bytes, and then it said, well, then you only have 9 integers can fit into that. You don't get 10 integers.
Another question is about what's inside the span itself. You mentioned there is a pointer.
Yes.
And the question is it the regular pointer? I mean, you're running under the buffer.
It's a native pointer. Well,
Let me explain the question.
okay.
I mean, you passed the array directly to the span.
Mm-hmm.
And usually there are some situations when you have a program which works under debug, but under release you have to put like something GC keep alive for the pointer. I mean, will this span and the pointer inside the span will keep the reference to the allocated array you pass into the constructor, so the garbage collector won't collect it.
Yes. That has to be true or the whole thing is useless. Right? Because then you would have memory corruption. Right? The garbage collector gets rid of the array, then you use the span, then you overwrite something else in memory. And that cannot possibly be true. Right? The whole technology would be completely useless if that were true.
Just because the span is the value type, and maybe because we are so concerned right now with 10, 16 years, we are concerned about the performance, and we do know that allocating the pointer to the reference object, it like makes garbage collector making some notice about the object.
It does. It keeps track of it. So what can go into a span is a pointer to the beginning of the object, but it can also be an interior pointer to within the middle of the object. But the garbage, both of those are possible. But .NET has always worked where even if you get a fixed pointer in earlier, I mean, you can still do it today, but even in .NET 1.0 or C# 1.0, you could get a fixed pointer within an array, a managed array, and the garbage collector would know it has to keep the entire array alive as long as that remains on the heap. It's actually that same technology that's being used inside Span. You just don't see it. You don't say the word fixed. You don't write unsafe code, which fixed has to be used in an unsafe context, but span does not. But it's the same underlying technology that guarantees that the object that the span is pointing into will live as long as the span lives. Yes. Yeah.
It's better to say that it depends on the runtime. In .NET framework, span can contain 3 fields. One is the usual pointer to the beginning and to the start and the length.
So,
And
true.
Yeah,
Yes.
.NET Core, because .NET Core knows about specific of span and there are only 2 fields.
Yeah, so what he's saying is true, that span is an implementation of the runtime, and in the regular .NET framework, a span object does have 3 fields on it. There's a pointer to the head of the object on the managed heap, and an interior pointer, and a length. In .NET Core, that's only 2 fields. It has a pointer to the beginning, which can be an interior pointer. They don't need the pointer to the beginning of the object, but then it also has the length. But this is really an implementation detail that you shouldn't have to worry about when you're working with span. The only difference that you might notice is that span on the desktop framework is a little bit slower and a little bit extra memory, but it's on the stack, so you're not even going to notice the memory. But it's a little bit slower working with spans on the .NET framework proper as opposed to .NET Core. .NET Core is a little faster. Yes? What types can be passed to this? So if memory serves, they have to be structures. Yeah, I think they have to be structures. Yeah? Yeah, right? From and to both are constrained to structs. And I think they have to be blittable structs. Okay, blittable means a structure that has no pointers inside of it. So only value types. A struct is a value type, and the fields must also be value types. All right, so now that's the next thing you can do with a span is you can cast it from one type of T to another type of T. There are some constraints on that, as I just mentioned. All right, the next thing that you can do with span is that I've been demonstrating you so far spans that are either on top, well, they're on top of managed memory. The first example was over a string that was in the managed heap. The second example was an array of T. The third example was also an array of bytes. But they're all managed memory. But a span doesn't have to be on top of managed memory. A span can be on top of stack allocated memory, and that's what this example is. So let's say you want to allocate a buffer. So I'll create a variable here called buffer size, and I've hard-coded it to be 128 bytes. Maybe you calculate this dynamically in your program, but I just hard-coded this in to keep the demo simple. Then I want to go and create a span of byte. But I have a little bit of logic here that says, well, if the buffer size is less than equal to 128, then that's a pretty small buffer. So let's do a stack alloc to allocate an array of bytes of 128 bytes on the stack. So this is going to allocate my array on the thread stack. But if it's bigger than 128, then I'm going to new up a byte array on the managed heap. So it doesn't matter how I create this byte array, on the stack or on the heap. In either case, I end up with a span of byte when I'm all done. But the beautiful thing here is that if I am able to call stack alloc, because the buffer size is small enough, then I've not allocated anything on the heap. So nothing has to be garbage collected. And so now I'm able to do this buffer manipulation, but on the thread stack. And when the method returns, then the stack just unwinds, and we free up the memory automatically. The garbage collector doesn't have to kick in. So we get really great performance, but now I have a way of doing an efficient way of allocating a buffer of dynamic size. So that works, and then when I'm all done, I end up with a span. For some reason, when you're in the debugger and there's a line that has a stack alloc on it, you have to hit F10 about 20 times, there we go, before it will go to the next line. I say that's a bug in the debugger. So what I call that. All right, and so now I can just use this span just like I did with the other spans. So I'm not using it here in this demo, but it would work just like any other span. I'm just showing you that I'm initializing it in a different way. A span can also refer to native memory. So it doesn't have to be on the thread stack, and it doesn't have to be in the managed heap. It can be in the native heap, and that's what this example does. In the system runtime interop services namespace, there's this Marshall class. It's been there since .NET 1.0, and it has a method on it, allocate handle to a global buffer. And then here I'm passing in my buffer size of 128 bytes. This returns back to me an int pitter, an integer the size of a pointer. Then I want to go and new up a span of byte, and there's another constructor on this. This is the first time I'm showing you this constructor. This constructor takes a void star as the first argument, so that's a pointer to some native block of memory, and then the number of bytes that are in that. And then I'm just saying, let's create a span of t out of it. Now, in order to call this to-pointer, I have to be in an unsafe block. So this unsafe is mandatory, otherwise the code would not compile, because you are doing stuff with native memory now, so you have to be in an unsafe context to do that. But now I've successfully created a span of byte over native memory. Just like up here, I created a span of byte either over thread stack allocated or over managed memory. So you really are seeing the three different ways of creating a span over the different blocks. Then in my try block here, I would have code here to actually use the span. I didn't put that in my demo, but you'd put something here. And then, of course, because you're manually doing memory management now, it's your responsibility to make sure you free up that buffer when you're all done. So I put that call to free hglobal here in a finally block to guarantee that I don't leak the native memory. All right, so those are the three different places where spans can come from, right? They can be a span over three different kinds of buffers. Any questions there? Yes, sir.
You can write methods that return span.
Of course. The asSpan extension method returns spans. Yeah.
What will if this method will return a span that you create from stack alloc?
Can you return a span that was created from stack alloc? No, you cannot do that. That's compiler enforced. Yes. Yes. It's a great question. Yes, if you create a stack allocated buffer and you have span of t. Remember, spans cannot be on the heap and they can't be boxed, right? That's compiler enforced. And if you try to return a span over a stack allocated block, the compiler will give you an error and it won't compile that code either. Otherwise, you would again lose the memory safety. When we cannot lose the memory safety. If ever you're thinking to yourself, aha, I think I know a way I can trick it so that I have lost the memory safety, you are wrong. I remember the early days of .NET. I used to think to myself, aha, I think I know how I can get the garbage collector to leak this object. And I would write all kinds of code and tricks and things like that. I think I figured it out, and I was always wrong. And it took me a while, then I realized, okay, I get it. The garbage collector, it actually always works. And then, you know, it was a good exercise to go through because I wanted to understand why does the garbage collector always work. So I would try all these different experiments, and then I would see that it always worked correctly, and I think, now I understand why. So same is true with span, but it will always work. If it doesn't work, you should not be .NET developers anymore. Right? It's a pretty severe thing.
Yeah, right.
Mm-hmm.
So in
Sure.
this unsafe part,
Yes.
you allocate span from the unmanaged memory.
Yes.
So what will happen if you pass here, say, buffer size *2, like double buffer size into the span compared to what you allocated really?
So I think in this case, if let's say I return the span from the method and I still in the finally free it, I can do that. And then you have memory corruption.
Yeah, I mean, the span can kind of can span
Yes, the span can span the lifetime of the native memory.
not only the lifetime, but also the size that I really allocated.
Oh yeah, sure, sure. If you want to put in here times 100, go ahead.
Okay.
But I would discourage that, right? But you're in an unsafe block, right? So you have basically said, trust me, right? I know what I'm doing. In which case, the C# compiler and the runtime will trust you. And if it turns out you don't know what you're doing, then that's on you. As long as you're sticking with all the safe code, right? There's no unsafe anywhere, then everything must be memory safe, and that is guaranteed. Okay, so now let's talk about working with strings efficiently. It is very common for people to build up strings and to parse strings. Right? Normally, we build up strings by calling toString, like maybe we would do a console write line, or maybe we use a string builder, and then we're passing in a datetime and an integer and a this and a that, and then toString ends up being called on all of those things. It turns out, in terms of efficiency, this is horrible. If you are creating a string with 5 different things in it, then toString is called 5 times, once for each of those things, to create these strings. Then those strings have to be concatenated into another string, and then the original strings are all garbage and can be cleaned up eventually by the garbage collector. So it's a very inefficient way to go. So with Span, the primitive types, all the primitive types in .NET now have a format method on them. It's like toString, but it can format into a span of char. Okay, and so I'll demonstrate that now. So here I'm creating an array of characters. It's a buffer of chars, if you will, and the buffer can hold 100 chars. And then I'm saying I want a span of these to represent this buffer. Now, I'm going to take this integer, 789, and instead of calling toString on it, I'm going to call try format. And it's asking the int32 type to basically convert this 789 into its string equivalent. But the format methods, they all take a span of char. If you can see from the IntelliSense, I know it's very small, but if you can see that, it takes a span of char here, and it returns the number of characters that are written into the buffer. So if I hit F10 to execute that, it says it wrote 3 characters into the span of char, which of course are the characters 7, 8, and 9. But now I have them as character representation instead of the integer representation. Now I want to go and insert a hyphen after that integer. So I'm going to go into my span, and this is using the indexer set property, because it's a span, not read-only span. So spans are read-writable, so I can use the set indexer, which is what I'm using here. And I'm saying, in this span, go to element 3, and go and put a hyphen in there, and then go and increment this by 1. So now I have in my buffer 7, 8, 9 hyphen. Now I'm going to call datetime now. This is not anything new. I'm sure you've done this in your lifetime. But now I have a datetime object, and I'm going to call its try format method, because all the primitive types now have this new try format method on them. And I'm going to tell it where within the span to write the string equivalent of this date time. So I take my string span buffer and I slice into it starting at character 4. So I want the date time to be starting at offset 4 within my character buffer. And then it's going to return to me the number of characters written for the date and time. And if we wanted to look at that, the date and time wrote 21 characters into the buffer. Now I'm going to take the total characters written, and which was 4 initially, but then I'm going to add the 21 to it. So now I know the total number of bytes that are written into my buffer of 100 characters. And now I'm going to take my string, I'm going to slice it starting at 0 to the number of characters written. So I'm going to ignore the stuff, the extra characters at the end of the buffer that I didn't write anything into. I'm calling my helper write method that does the for each loop that I showed you earlier, so that there's no memory allocations that happen here at all. And we see in the console window at the bottom the 789, the hyphen, and then the date time now. Okay? So the only memory allocation that occurred was right here on that new char array 100. And if I made this a stack alloc char array 100 instead, then I've done all of this with 0 memory allocations, which I could easily make this. In fact, I should do that in the demo. I should turn this into a stack alloc. I won't do it right now, but I will do it for next time. Then this whole thing is being done without any memory allocations at all. It's awesome. All right, and now this is taking that string span, and I'm going to slice it so that I'm taking the buffer of 100 characters, but I'm only grabbing the, I think it's 41 characters, right? It was my whole formatted amount. 25, rather. 25 characters. And then I'm going to call toString. So this does allocate a string on the heap and gives me back a string. So if you want to convert it to a string after you're done all this formatting, then you can finally call toString when you're all done, if that's what you want to do. And here's an alternative way of doing it. Here I'm newing up a string, and they've added to the string class a constructor that takes a slice of char. So I can pass in the slice here. These two lines of code do the exact same thing. It's just two different ways, syntactically, of doing the exact same thing. Okay. And now let's say you want to parse. So I have a string, and the string might be, let's say, a JSON payload or an XML payload, and it has lots of stuff in it. So the normal way of parsing this in .NET is you take this big payload of XML or JSON or what have you, and then let's say there's an integer in there. So you have to get the substring of the integer, pull that out, so you have to turn that into a string object on the heap, then you can go and parse that string into an integer. Or if there's a datetime, you have to pull that substring out as its own string, then pass it to datetime parse to parse that into a datetime. Again, you're making memory allocations all over the place to do very little tiny things, and then the memory gets garbage collected. So with span, we can improve that. So here I'm going to take my string span, and I'm going to find where the hyphen is in between the 789 and the November 20th. And now I'm going to call int32 parse. Now there's a new overload on all the primitive types for parse. There's new parse methods that now all take read-only span of chars. Just like they took strings before, there's now a new overload that takes a read-only span of char. So I can take my string span and I can say, let's slice it starting at offset 0 up to the dash. And now I'm doing a console write line, and I've parsed the 789 into its integer equivalent. Of course, calling console write line turns it back into a string and displays it on the screen, but just ignore that part. Okay. Here I'm calling datetime parse, and I'm going to take the same string and I'm going to slice it from after the dash to the end. That converts it into a datetime, but then toString is called on that because I'm calling console write line. And so that turns it back into the datetime over here. All right, so you're able to easily construct and parse strings now and avoid memory allocations using these new try format methods and these parse methods. Any questions there? Yeah. For GUID, yes, I am very sure the answer is yes. No, not too bad. So here's a constructor that takes a read-only span. Right? And here's a parse that takes a read-only span. And here's a try parse that takes a read-only span. Yes. And now let's get rid of that. Okay, this next thing I'm going to show you seems like it's really cool, but I'm really struggling to find out an actual reason why you would use it. So it feels like this is awesome for some reason, but I'm not sure what the reason is. Well, no, I think I just thought of a reason. I should change this demo to show that. Okay, so let me show you what this does, and then I'll tell you what I think would be this is a contrived example right here, but now I think I thought of a better example. So I'll do the contrived one, and then I'll give you the better example. So on the string class, there's a new static method called create. It takes a size. 26 characters is what I want this string to be. It takes an object. Anything here is whatever you want it to be. It doesn't matter what it is. In this case, though, I'm using an enumerable .range that starts at the capital letter A and goes for 26 letters. So it's the English alphabet, A through Z. And then the third parameter to this create method is a callback method. I'm using a lambda expression here. The lambda gets passed in a pointer to the string's characters. And they are mutable, not immutable. They are mutable at this point in time. This is very unusual in .NET. In fact, this is the first time ever you have ever been able to get the reference to a string and mutate it. This is the only place ever you can do that. And then whatever you pass here for this second parameter, it gets passed into the method, the lambda expression over here. So what I do in this method is I create a local variable n, and I set it to 0, and then I have a for each loop that goes over all the characters in the range. The range is A, B, C, all the way up to including Z. And then I'm going to take string chars, which is the pointer to the strings character array, and I'm going to write to them, because the string is mutable now, and each of these CH is converted to a char, cast to a char. And so really what happens is the runtime has allocated an array of 26 characters on the heap as a string object. It's calling this lambda and saying, here is the pointer to this array of characters. You can write to them inside this lambda, so you can mutate the string. When you return from this lambda, that string is now immutable from that point forward. So it gives you a way to allocate this string, write into it once only, and then use as a string from that point forward. So that was a little bit of a contrived example. This just proves that it worked. And what I think would be the good example is for me to do the formatting, right? This example up above where I was trying to format, I should have called string create, told it, well, you have to know how many characters up front. You can't figure it out dynamically as you go. Maybe it wouldn't work. You get the idea, though? You get it? Get it? Any questions on it? We'll have to think about the usefulness of it. It's a little bit, you have to know the size up front. That's part of the problem. Yes?
Does the compiler prevent leakage from the mutable span reference through a closure?
Does the compiler prevent the leaking of the span, you mean this guy right here? Well, it's being passed in.
Can I create a variable
Like here, as a span and use it in the lambda?
Yeah.
No.
String chars into this new variable so that it gets outside of the callback.
No. I mean, is there a way to do it? Yes. Can you use a span to do it? No. Which actually brings me to the next subject. Okay, so I don't know why, I'll try one more time to get PowerPoint to run, but I don't know why it's not running. Who's speaking? Oh, there you are. Well, one possible use case would be to change the byte order. But these are characters. I mean, yes, sure, you could. Yes, that's one possible use case. I wouldn't like to use it as a demo because it feels too advanced to me. But yes. So spans, you may recall from the table, which I can't make appear for you anymore. Spans cannot be fields in an object on the heap. They can only be on the stack. So if you created a local variable of type span here, and then you tried to use it in the lambda, the code will not compile. And I'm assuming that you know, but maybe you don't, that when you create a lambda that refers to some variable that's outside the scope of the lambda, the compiler turns the lambda into a closure. When the compiler turns the lambda into a closure, the local variable becomes promoted to a field. If the local variable is a span, when the compiler tries to promote it to a field, they can't do that. Spans can't work that way, and so you end up with a compiler error. And the compiler says, no, I will not do it. But sometimes it's useful to have a span be in a field of an object. And you can't create a span. In fact, if you just create a class or a structure, well, a class, let's do a class. You create a class and you make a span be a field, you'll get a compiler error. I actually have that here. Here, I have this commented out because it won't compile. But I tried creating this class, and I put a span of byte as a field of it. And when you compile the code, if you remove the comment at the far left, you get this error, C# error 8345. Do you believe there's 8,340? Anyway, field cannot be of type span of byte unless it is an instance member of a ref struct. What that's trying to say is you can't make this a field. It's a very convoluted way of doing that. Unless this happens to be a ref struct. You can make this a ref struct. But let's not get into the whole ref struct thing for right now. So you can't make this work. The code will not compile. However, that's where memory of T comes in. So memory of T allows you to, it's basically the same thing as a span, but it's a little bit less efficient than a span. But that's the downside. But the plus side is it can be a field of type. So I can't put a span of t here, but I can put a memory of t here, and that works. All right, but I'll come back to that in just a moment. So here, what I'm doing is I'm newing up in a buffer that can hold 800 bytes in a managed array on the managed heap, and now instead of calling as span on it, I'm calling as memory on it. This, of course, returns to me a memory of byte instead of a span of byte. Now, with memory, I can't get my PowerPoint slide up, but there is no enumerator and there is no indexer. So you cannot get an element and you cannot set an element. There's no indexer at all. So you cannot get or set an element of what this thing points to. So really a memory of t is a pointer to some block of memory, but it's a factory of spans. So from a memory of t, you can create a span. And from a span, you can then index into the span. So that's what I'm doing here. So I've created this type called Utf-8 Buffer Formatter. This is a class that I wrote. I'll show you the code in a moment. And it takes in its constructor, a delimiter is the first parameter. I'm just saying I'm going to put a bunch of things into a buffer, and I want those things to be semicolon delimited. That's the delimiter I'm using. And then here, I'm passing in this buffer. Now, the buffer is a memory of t, not a span of t. And if we step into the constructor here, you can see it's initializing the fields. The problem here is that when I try to write this with a span of t, I then, inside the method, try to set the field to the span of t, but I couldn't have the field be a span of t, and so it wouldn't compile. Right, so I made the field be a memory of t, so now the constructor takes a memory of t, and now I can copy a memory of t to a memory of t. Excellent. So now what I'm going to do is, I seem to be jumping around all over the place, but it's not. Oh, I see what happened. Okay. So now we'll initialize the constructor here and come back. So now I have a method on my Utf-8 buffer formatter. Oh, by the way, this demonstrates a couple things. First of all, I'm demonstrating why you need memory of t. Another thing that I'm demonstrating with this example is how to work with Utf-8 in an efficient fashion. The .NET framework has been hammered by people who are saying that working with Utf-8 is very inefficient. And of course, when people are making HTTP requests and responses, that's one of the most common uses of Utf-8. And people do that all the time. So they've added a bunch of Utf-8 functions in so that you can format these strings quickly and easily. I also notice I'm running out of time, so I'm going to move a little bit more briskly here through some of this. There's a new type in .NET called Utf-8 Formatter. And it has methods on it like try-format, and there's a bunch of overloads. There's an overload that takes a bool, there's an overload that takes a byte, there's an overload that takes a date time and a date time offset, and so on. And so I want to call all these methods, and I want to format the byte or the boolean or the whatever into my buffer, but using Utf-8 as the format. And so I have this helper method, end span. Where did I go? Here it is, end span. Okay. And it takes my memory of t, and I cannot index into a memory of t, but I can get a span from a memory of t. And once I get a span from it, I can then slice into the span or index into the span. So this is taking the buffer, it knows how far into the buffer I am, and now it's going to try to append a boolean into it. Sure. And then it's going to also append the delimiter, which is the semicolon after the boolean. And then I come back, and now I'm going to put a date time into the buffer, and now I'm going to put an integer into the buffer. And so if we looked at the whole buffer now in Utf-8, we would have true, semicolon, the date time, semicolon, and then the integer 1, 2, 3. Then I wrote an equivalent type called Utf-8 buffer parser, which is going to go and take the original memory of t, the buffer, slice it so it's exactly the size of what I wrote into the buffer, and then I'm saying use semicolon as the delimiter, and now I'm going to go backwards, and I'm going to say, okay, so let's parse the first token out into a boolean, and let's parse the next token out into a date time, and let's parse the third token out into an int32, and then here you see at the bottom that it works successfully. And again, I am allocating memory for this Utf-8 buffer formatter, right? Because this is my own class, so I allocate that. And then it has some memory buffer that I'm using, which I allocated as an array on the managed heap, but it could have been a stack reference thing, or it could have been a native memory thing. Either of those would have worked. And then I am now appending into it, and then I'm parsing back out of it, and none of that do I do any additional memory allocations for. And the very last thing I'll show you before we end is working with streams efficiently. The way I'll just do it this way is that here I have a memory stream, but memory stream, like file stream, like network stream, they're all derived from the same base class, system IO stream. And system IO stream has a new overload for the write method on it. And the write method here, you can see, takes a read-only span of byte. So given any stream now, a memory stream, a file stream, a network stream, you now have a synchronous write method on it where you can pass in a read-only span of byte so you can efficiently take memory out of native memory or out of the stack or out of the managed heap, and you can go and write it to the stream. There's also an asynchronous write async method, it's this one here, that takes a read-only memory of byte. Notice this one doesn't take a span, but it takes a memory because you're doing an I/O operation and the lifetime of the object has to live across, so they have to make this a field. So that's why it takes a memory and not a span. And similarly, if we look at read, there's a synchronous read method now that takes a span of byte. This is not a read-only span because you're going to read into the span, so you're going to be writing to the span. And there's also a read async that takes a memory of byte. And those are the new methods that are available on streams for working with spans in an efficient way. And now you have seen everything. Okay, this example writes to it synchronously, then writes to it using the async version, but then it does it synchronously with the get await or get result. Then I reset the stream back to the beginning, position 0. This is on span. If it's a read-writable span, then you can call clear. That clears out all the elements of the span. So I'm taking this memory up here that had 1, 2, 3, 4, 5 in it, and I'm clearing it all out so it has all zeros in it. And then I'm going to read into the span from the memory stream, and if we look at the data, we have the 1, 2, 3, 4, 5 read back in. So this proves it round-tripped the data. I wrote it to the stream, I reset the stream, I read it back from the stream. Everything is working fine. And then I'm using the async version here. Right? So the sync versions, they work on spans, so I have to convert the memory to a span. And the async versions, they work on memories, so I pass in memories. And that is the whole demo. Are there any questions on any of this? Yes, sir.
Can the spans memory can be useful for Bluetooth communication?
The question is, can you use spans for inter-process communication? The answer is yes. The most efficient way of doing inter-process communication is with a memory map file. If you have the offset to the memory map file and the length, then you can definitely create a span over that in 2 different processes. And one can write to the span, and the other one can read from the span, and you've done inter-process communication. Well, what are you putting into the span? So if it's a rectangle, then you might want to serialize the rectangle into the span and then deserialize it on the other side. Okay? Yeah. Yes?
But general question. In general, is it a good idea to use .NET for such extremely performance-sensitive components? Doesn't it better to write these components in C++, for example, and use .NET for everything else? Because all of this looks a little bit tricky, not the usual way we write code.
So the question is, for really performance-sensitive code, does it make more sense to use native memory? Or a native language, right, like C or C++? I would say that because of this, the answer is no. In native, I did C, C++ with Win32 for years. And if you look at what that code looked like, it looks a lot like this. I would allocate a byte array, maybe on the stack or maybe on the heap, and then I would be formatting things into it. And to all those Win32 methods or C methods, you pass in a starting pointer and you pass in a size. Now, if that code looks the same, but now you're doing it in C#, and unless you use that native memory with the unsafe keyword, and you're guaranteed that everything is safe. Now, yes, C and C++ will still be faster. It will be faster. If you're really, really performance sensitive, it will be faster. Another thing that you could do and have been able to do since .NET 1.0 is you've been able to use unsafe code. So there have been times I've been writing C# code, and I said, man, I really want this to be fast, or I want to use interprocess communication with memory map files. I love memory map files. And so in my C# code, I'll throw a little unsafe code in there. Not a lot, a little bit of unsafe code, right? I always encapsulate it in a class, right? So I will create like Jeff's helper class, and inside there will be the unsafe code. So anybody using Jeff's helper class does not use unsafe code, right? Then I test this heavily to make sure that I don't have any memory leaks or data corruption in there. And then if I feel really good about it, then I let other people use it. Which is the same thing that happens in .NET, right? There's a ton of types that are in the base class library that have unsafe code in them, but it's written by people at Microsoft, and they test it, and they have code reviewers for it, and they really make sure it's good. And then everyday programmers like you and me, we use those types. The unsafe stuff's happening under the covers, but we don't know it, and we just trust it. Right? Yeah.
These APIs that accept spans, as far as I remember,
Uh-oh.
they are now kind of available in .NET Core, but they are not in the full framework. Like Stream API does not have span accepting methods in the full framework. At least according to the document.
Yeah, that's right. So the full framework support for this is not fully available just yet. That is correct.
Do you know any plans or?
Yeah. There's definite plans for it. I mean, if you're asking me, do I have a date? No. I don't have a date. But I do know that they're going to do it. So they want to make sure that the code that you compile on, the code you write works on .NET Core and works on the .NET Framework. Now it's slightly slower on the .NET Framework when using Span than it is on .NET Core, but the code will work correctly. But they have to add these methods to the .NET Framework proper, and they've not done that yet, but they will. They've committed to doing that. Okay. Yes.
Have you tried if we create a span from array heap,
Yes.
enumerate its elements, then change the initial array, and then enumerate again?
Yes.
Change.
Yes, that's right. It will change.
And then the same question for memory. If we get memory, then get span from this memory and change
You mean like native memory or stack memory? Or just
memory of heap.
memory? Oh, from memory of T? Yeah. They're all indexing into the same thing.
So if we change to in span, the memory will change too.
Yes, that's right.
And if there is another process writing into this memory map file which is mapped into your span, then you will be like reading same index every second. You will see changing value.
Sure. The same is true if you have two threads in the same process, and they're accessing the same elements of the same array, right? That would happen in .NET for the last decade and a half, right? So the same is true if I have one span or one memory, and it's being used by multiple threads simultaneously, then all bets are off, right? You won't have you won't have data corruption. Like, you can't go beyond the elements of the array. You could have data corruption, and that one thread is writing while another thread is reading. You have a race condition. That you can have. But you cannot access memory outside the span in any way. Yes, sir.
What method clear does on span? Does it just
Goes through all the elements and sets them to 0.
memset like in C++?
You're asking about the performance characteristics of it?
If I will have span from class, what will method clear it will set?
Span is of an array of something. So it's not a span of a class. So you mean a span of rectangles? Are rectangles value types or reference types in your example? If it's reference types, then it's going to set all the references to null. Okay? If it's value types, then it sets all the fields to 0. Okay? Any other? Yes, sir. Does for each over span allocate memory on the heap? No. Simply doing that, the answer is no. Maybe if you do something inside the loop, the answer might be yes, but simply doing that, the answer is no.
Second question, will Runtime have any optimizations for span memory, like bounce check combination,
Yes, yes, there is bounce checking, elimination, and there's some other things that the compiler does. So span and memory, they're not written in C#. They're written in native code. They're intrinsics to the runtime. So the runtime, especially on .NET Core, as I said, span of T on .NET Core has 2 fields. Span of T on .NET Framework has 3 fields. And there's other optimizations that the jitter does when it's working with spans. Yes. Any other questions? Okay, go ahead. You want a method that takes as a parameter a span of T? No. Oh, yeah, you should be able to do that.
Able?
Yeah.
What about an enumerable? If I yield some result, I will create some state of object as well.
Well, so you didn't say you were making it an iterator. Well, if you implement it as an iterator, your enumerable, then you will have, okay, you're conflating 2 things. First question was, can I have a method that returns an enumerable of span of T? I'm pretty sure the answer to that is yes. Now you're saying, if I implement it as an iterator, can I use a span of T inside? The answer is no, right? You would have to make that a memory of T, but then you could yield return the memory of T dot span, right? And then you can return an enumerable of span of T. It's a compile, right? It will not compile. If the compiler tries to promote your what looks like a local variable span into a field, it cannot do it, and the compiler will say, no, I cannot do this. So then you will have to go and change it to memory of T. Yes, sir.
What's the important difference, or do you have any difference between field when we pass and clear?
Field when we pass, so I don't know exactly how clear is implemented internally. My guess is it is some native code in the runtime that does like a mem set that somebody suggested that just blasts 0 into the whole range. But I don't know for a fact, and it's an implementation detail that could change with different versions. You have something else? Yes. Yes?
Can we declare read-only ref struct?
Yes? Yes. Yes. So his question was, for those of you who didn't hear it and the people on the videotape, is that C# has a ref struct. It also has a read-only ref struct. His question is, can you have a ref read-only struct? And the answer is yes. You can combine those things together into a single thing. So a ref struct means it's a structure that can only be allocated on the stack. So you can actually define these yourself. The span of T is a ref struct. And you can, and if you want to create your own types that are only allocatable on the stack, I don't have a good reason why you would want to do this, but if you wanted to do this, you could. You can declare your own structure and make it ref. And actually, I think read-only span of T is probably a ref struct. Right, so where's read-only span of T? Here, if we go to the definition, it's probably a ref read-only struct. Well, it doesn't say. I think this is incorrect. I think Visual Studio is not up to date with the latest possibilities, but I think that this is a ref read-only struct.
The indexer returns ref read-only.
Yes, there is this here. Well, there's this here, and you said the indexer. Line 16. Yeah, okay. So there's a ref read-only T there. So it's doable. Okay, so I'm happy to take questions on other things too. Do you really want to end at 9, or I'm happy to go later if we can go a little bit later? It's up to you, or?
Yeah, it's up to you, actually.
It's up to me. He originally said, how about I do 2 hours? And I said, no, 90 minutes. But I'm actually feeling really good. So I'm happy to stay a little bit longer, and we can talk about anything else if you'd like to talk about something else. Anybody want to kick us off with anything else?